Everyone, please look here. Everyone, please look at here. Look at the board. Okay, now what is the specification? So the input was 4-bit BCD. I call this as capital A, capital B, capital C, and capital D. The output is a 7-bit. The segment A, B, C, D, E, F, and G. Display should be off for. Okay, now can you see in the specification? Display should be off for non-BCD input codes. So for 10 to 15, all output should be zeros. If we say we want to ignore non-BCD code, so then the display, it will be X, don't care. Please remember. So it depends on the specification. The specification is explicitly saying that display should be off for what? Non-BCD code. So from 10 to 15, all will be 0. Okay, now we draw what? We do the formulation. And what is the formulation? We have transformed a real world problem into a truth table. And you know how to derive this truth table. Okay, now we derive this truth table. And if you look at the segment A, how many ones are there in segment A? 1, 2, 3, 4, 5, 6, 7, 8. 8 ones are there. Got it? Now, what we do? We do the logic minimization using CAMF. Now we are using CAMF. We are using CAMF. We use some CAMF. Okay, who did? You did? Who derived the expression for the CAMF? Raise your hand. Okay, and please compare your solution with my solution. Can you see it? Is it the same expression or different expression? For you, same? Then it's good. It means you're good at Carnot map. If you're good at Carnot map. So this was just like a practice for you that you're good at Carnot map. And please remember, in exam, I will give, at least in the second exam, I will give you Carnot map problems, bigger Carnot map problems. This is the expression for what? Which variable? A. Now this is expression for what? B. And please look at here. Everyone, I need your attention here. Can you see the color coding? I put a lot of efforts just for you. Just please, when you go home, if you didn't complete it now, please go home and try to solve this on your own, and then compare your solution with my solution. So if you look at here, the green color, so this is green, this color is pink, it's pink, this color is red, this color is red. I tried to use the same color so that you know, and the same thing is true for B, and the same is true for C. Okay, so now okay, and we will. I will come to you again. I will come to you again. Now, not now, but just let me explain something. Okay, now, without everyone, please look at the board, and I want to ask some question. What is your observation? Now, initially we have derived the expression for A, B, and C. What is your observation looking into the expression? Is there any room for optimization? What is the room for optimization? Can you see here? A bar B is the common term. So A bar B is used here. A bar B is used here. Where is A bar B? A bar B is used here. And A bar B is used here. We have another common term. What is that common term? B bar C bar is here. B bar C bar is here. And B bar C bar is also used here. So these are like some room for optimizations. So now we also look for these optimization opportunities. And this opportunity, and we should do some kind of algebraic manipulation here. Some problem may be complex, some problem may be simple. So if some problem are complex, you do some algebraic manipulation as we did in the previous slides. So I will also give you some problem, and I will give you for the homework, and then you see what kind of optimization can do. And if someone did the best optimization, he will get some bonus marks, and I will add them to the midterm. So there will be some challenging problem for the homework. Okay, if two guys' solutions are the same, no bonus mark. So please don't share your solution with the other one. So this is also another. Okay, so now we need to extract the common term. What is the common term? A bar B, B bar C bar, and this. So can we rewrite all of these other expressions? Again, we rewrite this expression. So now T1 is A bar B. So A bar B. So it means T1 B. Got it? Now, if you look at here, now T1, T2, and T3 are the shared gates. Why T1 is the shared gates? Because these are T1, T2, and T3. What are these? Common terms. We have extracted the common terms. We have extracted some common terms, and then we see, oh, T1, T2, and T3 are shared gates. And we do the same kind of optimization for other variables. What are other variables? No. What are other outputs? D, E, F, and G. So similarly, we already do the logic minimization for the other variables. We do all the magic, all the color coding. Please look at the color coding and all things. So that we say this. So now what is D, E, F, and G? And we did this. Got it?
You will post long questions like this.
No, I will not post this kind of long question, but this will be specially for the homework. But I can have a reduce for that. Now, now what's the question? Please remember, how many inputs are there? 4-bit. So I can also say, okay, if the input is 2 bits, I only want to display what? 0, 1, 2, and 3. So the input is 2 bits. You want to display 0, 1, 2, and 3. So then there's a Karnaugh map. How many bits Karnaugh map? 4. We have 4 entry Karnaugh map. So you can have 7 and it can be solved easily. Got it? So I will have this kind of reduced problem like divisible by through. I can have multiple functions. In the previous example, if you remember, I have function f1, f2, f3, and f4. F1 was the majority, remember? F2 was the even function, f3 was the odd function, and f4 was divisible by 4. Okay, now this is a very interesting thing. Anyone, I may also give some bonus mark to some students. And please think. And I can give the answer in just like in 5 or 10 seconds. Assume that we have an n-bit number. We have an n-bit number. So we can say a n minus 1. Any n-bit number start with n minus 1. Then what is the second bit? N minus 2, blah blah blah, until what? A0. We have some output E1. We have some output odd. We have some output divisible by 4. We have some output divisible by 8. We have some output divisible by 16. Derive the expression. Bonus question of bonus mark. So divisible by 16 will be 1 if the number is divisible by 16. Yes. There is no need for truth table here. No need for truth table. No need for truth table. Assume n is equal to 5. So you can say, so n is equal to 5, so 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 1, 0, 0, 0, 1, 0, 0, 0, 0, 1, 1. Please look at here. What is this? 0, 1, 2, 3, 0, 0, 1, 0, 0. What is this? 4, 0, 0, 1, 0, 1. What is this? 5, 0, 0, 1, 1, 0. 6, 0, 0, 1, 1, 1. 7, 0, 1, 0, 0, 8. Okay, please think. Okay, now if you look at here, even. If the least significant bit is 0, it is even. So even is what? A0 bar. If it's 0, it's 1. Okay, odd. What about odd? A0. And look at the pattern for divisible by 4. This one is divisible by 4. 0 is divisible by 4. And 8 is divisible by 4. Look at the last two term bits. These two bits, and these two bits. What's the observation? A1 bar, A0 bar. Last two bits are 0. Divisible by 8. A2 bar, A1 bar, A0 bar. Divisible by 16. Got it? So now this kind of questions, I will ask one such kind of question in the exam for the A grader. Because some student got 64.5 and getting an A in my course is not easy. Okay, so that's a, so this is a thing. So you need to also think. So one question, this kind of tricky question, will be for the A grader in the midterm. 2 questions from the slides. Similar question. I will reduce the complexity. If it's a BCD to 7, so it's a big complexity. Let's reduce the complexity. but please try at least this question at home. Okay, so now if you look at here, now we did it. So now we have expression for D, E, F, and G. We identify all these things. We minimize all the expression. So these are the common terms. We got these common terms. And when we look at here, so how many common terms are there? 9. So we say what is A? T0 plus T1, D plus T4 plus T5, and we identify all these common terms. I did a lot of efforts, a lot of work. You do this, but it is your homework. If you do this, and believe me, if you at least solve this problem, not one time, how many times? At least 3 times. If you solve this question 3 times, you will learn a lot of things. And then you compare your solution with this solution. This is, if you're doing this, your second midterm will be good. If you're not doing this, practice, then you may face some problems. Okay, now we are only showing the output for E, F, and G. What is the output of E? Can you see here? What is E? T5 plus T7. So E is T5 plus T7. Okay, T7 is here, and where is T5? T5 is there. What about T5? What is T5? Look at here, T5. What is T5 now? B bar, C bar, D bar. So T5. So can we see here? Now T5 is actually what? T2 D bar. So now we are using the logic sharing approach. And now this is all, why I'm not going to explain each and everything. I can do this by hand, but it will take the whole class. It will take the whole class. So now it is, and I did it with a lot of animations. I use all the common terms. Can you see the color coding of all these terms? So I did this thing, but then you should do it on your own. Go home and try to solve this problem. Yes, please.
For midterm, do you include the inverters or without inverters?
Which one?
For midterm, for the
Yes, so if you say A bar, B bar, so for A bar, B bar, we also, okay, for B, we need, so we can say, okay, if it's B bar, I assume that we are using an inverter for it.
So we don't need to know the inverter.
No, just it's simple, because for B bar, we know we only need one inverter, so it doesn't matter. Got it? So you can also write something like this, like B, it will become B. Any question? Should we proceed? Okay, now, did we do the adders
Yes.
in the last lectures? Okay.